Okay, so starting here again, thinking about slope fields. Now, when I'm looking at this differential equation, so I see this negative x over y, so this is the first one to write down in your notes today. dy dx equals negative x over y. So remember that a differential equation is just an equation with a derivative. And so it's an equation. This one's different in the sense that it's involving both x and y. And I don't think we really saw that yesterday in this class. True? Only just right at the end, real quick. So as we look at this, though, we can see the circles, right? Can you see the concentric circles about 0 as it's coming out there? When we think about different solutions to the differential equation, notice that there's really like two halves to the solution. There's a top half, which is corresponding to the top half of the circle, depending on the point I was interested in. Or if the point is then negative, I would get the bottom half of the circle. Okay. So thinking about solving for c, thinking about you would get a y squared or an x squared, right? When you're solving for c, because that square root, that's the plus or minus two different answers, okay? Now, I want to remind you again of how we would have gotten such a derivative. So let's write this down. Let's start with x squared plus y squared equals 25. So if I would say take the derivative of this, this is definitely first semester kind of topic. And so the derivative of x squared is 2x. The derivative of y squared is 2y, don't forget, times dy dx, chain rule, equals 0, not 25. Again, it's tempting for people to say 25 there. And notice when you solve this, negative x over y, which is the differential equation that I have that we're starting with. Can you justify for me why concentric circles? Like, why does this, in terms of slope field, produce concentric circles? Like, when you think about the equation and the work that we're doing, then what do you think? You mean like these coefficients here? Yeah, these coefficients will be the same in a circle. So then as you do that division, it's always going to end up being a -1 and a 1 because you're going to move that over. There's one other piece maybe to add to that. How come we can see circles of radius 2 and 3 and 4 and 5 and 6 and 7? What happens in this process that gets lost in this last step? The constant's lost, right? Isn't the 25 the thing that's defining the radius? Radius is 5. And so that is lost, and that's why here, if I would look at the slope field, I see all the circles, basically. Okay? Remember, connect the dots of the slope field is the solution, is the original function, right? Connect the dots in the slope field is not this equation, but the thing we took the derivative of to get that equation, thus the antiderivative. Okay. So let me go back here. What I want to do is turn that off. I'm going to pause it for just a second, and I'm going to change this differential equation because I did that yesterday, so we're going to do something like that again. And so, and then I'm going to want to see if we can figure out what possible things could be there. So I'm going to pause. A lot of the homework I gave you yesterday was talking about wanting you to kind of look at a slope field and then try to match it to some possibilities of some things that they gave as options. So some of that was matching, some of it was like choose the right one, what are the things possible. So I want to talk a little bit about strategies or things to think. Like as you're looking at this slope field, like one thing, so one strategy of identifying identifying what you're looking at. So strategy one, I want you to put in your notes, is you need to examine the slope field, both left and right and up and down, and notice which direction causes change. Okay? So we're going to examine the slope field left and right and up and down. Now, in this one, when I look left and right, what does it appear is true about the slope? As I look left and right, how would you describe how the slopes are behaving? You're looking up and down if you say that. It's the same. What do you mean by that? So for a given y, it looks like x doesn't matter. How about that? For a given y, it looks like x doesn't matter. What does that tell you about the differential equation? Say that again? There shouldn't be an x in it. The differential equation here is a function of y. So the one we saw yesterday, when we sketched it, as we went up and down, we said, oh, it's going to stay the same. So this one, as I look left and right, it's going to stay the same. Okay? So that means I need to think about what a possible answer here is. And again, as we're doing this, it's right now we're more doing like a process of elimination, because if you're just looking at this, it's really tough to decide what you think it is by connecting the dots and then trying to find the derivative. Like, that's not going to happen here, okay? But there are some things I could notice. So here's strategy number 2. We're going to examine the slope field for regions that have positive or negative slopes, okay? We're going to examine for regions or sections of the slope field that all have positive slopes or all have negative slopes. So in this one, where are the slopes positive? Try again. Be more specific. Tell me mathematically. Yes, if y is greater than 0, it looks like we have a positive slope. Okay? Now notice, kind of the reverse also seems true. If y is less than 0, we would have a negative slope. Now, notice that that starts to give us maybe hints about the slope field. Okay? Third strategy. So third strategy I want you to write down. Look for slopes of 0. Examine the slope field for horizontal tangents, slopes of 0. Now in this one, it looks like it's the x-axis. Do you see that? They're kind of on top of it a little bit there, but okay, so we're supposed to be looking for where it's positive, looking for where it's negative. Is there any pattern to that kind of thing? We are looking left, we're looking right, up and down, looking for changes, and we're looking for zeros. Those strategies are really going to help try to identify these. Now, I chose something really simple here. Okay? So I'm going to give a couple possibilities. So let me actually put this in another screen so I can draw on it. I'm going to give you some possibilities, and I want you to try to rule out what I typed. Okay? So take a minute at your table. Think about what these 4 would be saying. You know, I'm telling you the equation for slope there, right? Derivative. So I'm telling you the slope for that first one is the y value of the point squared. So if I put a point somewhere and go, so this point right here is 3, 3. So I should be able to use the y value of 3 in these and try to understand, does that seem to make sense or not? Okay? So the right answer is on the right. Which one is it? Take a minute, talk that through. Anything here that we can rule out? Tell me something we can rule out that you're certain is not the right answer, not the slope field, not the differential equation I typed in to make this theory. Yes, so this one is definitely not a possibility. So, sorry, it's frozen. That if y equals 0, she said the slope should be -1, so therefore it's not, so it's wrong. Okay? In fact, if it were y minus 1, where would the little horizontal segments have been? Careful. At 1, so if y is 1, then 1 minus 1 would be 0. We should have saw at 1, which is right here, this first mark, we should have saw little horizontal segments here. That's why paying attention to horizontal little segments is helpful. Okay? So it's not that one. Okay, anything else here that we can rule out? Yep. Tell me why y cubed plus 1 can't be it then. You're right, keep talking. Yes, and so here's the thing I want to be a little careful of, that it's really hard to know if that slope is 2, right? But I like the thought of the reasoning for the same reasoning, because now go back here. What if y is 0? If y is 0, what does this say the slope should be? 1, and it's definitely not. So be a little careful of like saying, oh, that doesn't look steep enough, because it's really hard to judge the right steepness. It's not too hard to judge horizontal. Okay, so it's not y cubed plus 1. Okay, we're down to 2. Yep, you can. It's not y squared. The answer was y. Why not y squared? Everything should have been positive, right? We should have seen positive slopes everywhere. Or 0. It could have been 0. Like that one works for this quadrants 1 and 2 and the x-axis, right? It doesn't work for quadrants 3 and 4. So what you would actually have seen, if it were y squared, wouldn't you have seen these same slopes in these quadrants translated down, right? Like, so if it doesn't matter if y is 3 or -3, that you should have the same slope. You would see this kind of symmetry about that slope field. Okay? Good. Let's try another. So, give me a second here. Let me change it. So here's a new one. So look at your 3 strategies I've given you. So look left and right and up and down. Does it involve both x and y or only one? Notice where things are positive and negative, and also notice where there are horizontal segments. So take a minute, take that in. I'm going to give you some options here again. Okay, so first, are you expecting the differential equation to involve x, y, or both? Definitely both. So all 4 choices here are going to involve both. So let's give some options. So how about this one? How about this one? How about this one? This one. Talk it over. Can you rule any out? So here's a hint, like the zeros are actually a very helpful way to figure out which one it is. So I'm noticing little horizontal pieces in here, right? Did you notice that? Yes? Are you awake? Horizontal, horizontal, horizontal. In here, do you see that horizontal little segments that are happening? Yes? Don't try to read the grid. Not yet. Like I can help with that in a second. But I mean the little gray lines are all by 1. Okay? Now, if I'm noticing little horizontal segments here, I'm going to look back over here for just a minute, and I want to think about slope equals 0, right? Because that's what we're saying. So if I would take this one and say, okay, if the slope is 0, what y produces a slope of 0? Negative 2x. Oh, well, do you see that that's totally wrong then? That this line is definitely a line of a positive slope. So if this were the case, what we would see is this line at y equals negative 2x that has little horizontal segments all along it. And we don't have that. Take a second, write a comment down about how solving equal to 0 should give the equation as to where the 0 slope should be happening. That is a huge hint to decide the right answer for this question. And again, so this grid is by 1, so that's 1, 2, 3, 4, etc. But it's not this one. Can you tell which one it is? Can you rule another one out really quick? If it's not 2x plus y, it's also not which other one? Yeah, it can't be this one, because it should have negative slopes going this direction as well, right? When you solve that, so let me say it another way. If the x value is equal to negative 2y, wouldn't that slope be 0? Right? If that x right there happens to be equal to negative 2y, the entire slope would be 0. Where will x equal negative 2y? Well, along the line, negative 1/2 x. Well, that's not true, so it's not that one. 30 seconds at your table, which one is it? Which one is it? Is it x minus 2y or 2x minus y? I'm hearing votes for this one. So if it's that one, shouldn't it also be confirmed by looking at the positives and negatives, right? So do you notice that if I think again about this line, so this line is actually the line y equals positive 2x. Slope here is 2. I'm sorry, how about a half? Up to over 4 is using the grid here. So if you think about points on this side of the line, so all the points up here, doesn't that mean y is greater than a half x? Like if you remember like your inequalities and the solving that you did, right? The y values are bigger than the values of the line. Now, if you think back over here, if y is greater than a half x, how does it confirm all those negative slopes? Why does that make sense? So I'm saying above the line, those arrows should be this statement. If I take that statement and I put it back here, it makes sense why this entire region has little negative slopes. 30 seconds to your table. Tell somebody what I'm talking about. If you don't understand, listen. Who can say that? Who can say why those slopes are negative above the line? Algebraically. Go ahead. So it's got to be negative then. Yeah, so if you just think about, like, if y is bigger than a half x, and the first thing I do is double it, right? Doesn't that say that 2y is greater than x? And if I'm subtracting it, then I'm subtracting more than the first piece, so it has to be negative. Like, it's just kind of, you can pick some numbers if you're not following that and go through. So here's the answer. It's not this one. Okay? Let's do another one.